Section 3.3 is about proving lines are parallel. So this first theorem, the converse of the corresponding angles theorem, it says if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So if I have two corresponding angles that are congruent here, I'm going to know that these two lines, L and M, are going to be parallel. Let's take a look at the first example. It says, which lines are parallel if you know 1 and 2 are congruent to each other? Well, notice 1 and 2 are corresponding angles. So if these are going to be corresponding angles, then I know that, here would be my transversal. So both of the angles are on the same line. That's going to be my transversal. So therefore, A and B would have to be parallel to each other, and to justify it, I would put by the theorem, so by the converse of the corresponding angles theorem. So the tricky part is kind of seeing what the lines are, but whatever line the angles are on, that should be your transversal, and then the other two lines that intersect through that would be the lines that are parallel. Pause the video and try the got it question. So in the got it question it says, which lines are parallel if 6 and 7 are congruent? So 6 and 7 are corresponding angles. They lie on line B. So the two lines that intersect through that would be lines L and M, and then my justification would be by the converse of the corresponding angles theorem. It is very important that you put converse in there, because remember we already had corresponding angles theorem, and that was if I had parallel lines, and now you're trying to prove it. So it's very important you use the correct one. Alright, next one. Up at the top here I have some more converses. So it says if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. So 4 and 6 are alternate interior, they're congruent, so therefore L and M have to be parallel. Next, if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. So 3 and 6 are same side interior, I know that they are adding to 180, so therefore L and M have to be parallel. Last, converse of alternate exterior. If two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. 1 and 7 are alternate exterior, they are congruent, so therefore L and M have to be parallel to each other. Let's see how we can use this. So here is my first problem. It wants me to find the value of x for which A and B would have to be parallel. Well, if these are going to be parallel, I look to see what kind of angles these are. So the first thing I notice that those angles are same side interior. And according to the converse, same side interiors have to be supplementary in order for them to be parallel. So I would have to add these two and set them equal to 180, because they would be parallel if and only if the angles are supplementary. So then I would solve. So I combined my like terms, subtracted 120, divided by 2, and got x equaling 3. You're going to pause the video and try the got it question. In the got it question, you should be seeing that these two angles are corresponding angles, so if they're going to be making C and D parallel, they would have to be equal to each other. So I would set them equal to each other and solve. So I added 2, divided by 3, and got W equaling 19. So you want to make sure that, first of all, when you're talking about these, make sure you're using the correct name. So make sure you're using converse versus just the regular theorem. And then again, it is crucial by now that you know what kind of angles we have as far as corresponding, alternate interior, alternate exterior, or same side interior.